Right now, in China, a facility is producing fuel directly from the air around us. No drilling, no oil fields, just common air and water. The same nation recently created a system that stores energy by freezing air, capable of powering a city for hours on demand. They are generating advanced chemicals for rockets using only sunlight and seawater. And they achieved a new milestone in their efforts to replicate the power source of stars within a controlled environment, one that could eventually supply endless clean energy. 6 separate advances unfolding simultaneously, all linked to a central objective that has received surprisingly little global discussion. By the conclusion of this video, you will see what that objective involves and why it may determine global influence for the coming century. If this topic interests you, please like and subscribe to stay informed about future developments. What follows is not a single innovation, but 6 interconnected efforts quietly reshaping energy systems worldwide. The final breakthrough may be the most striking of all. Let us begin with a challenge that rarely makes headlines: the overlooked vulnerability. China manufactures more goods than nearly any other nation. Electronics, vehicles, machinery, and countless everyday items trace back to its factories. These operations run continuously while cities expand at unprecedented rates. Pick up almost any product globally, and there is a strong chance components or assembly originated in Chinese facilities. Yet this expansion demands enormous energy. Much of it still relies on imported oil. Over 70% of barrels consumed arrive from abroad, primarily the Middle East, Africa, and Russia. The true issue extends beyond sources. It concerns delivery routes. Understanding this path explains why later developments feel strategic rather than coincidental. Every shipment crosses oceans aboard tankers. Nearly all pass through one critical waterway between Malaysia and Indonesia, known as the Strait of Malacca. Imagine a narrow funnel. The wide opening draws from the Indian Ocean and tankers from distant regions. The constricted section allows ships to proceed only in sequence, like traffic in a single-lane passage. At its narrowest, the strait measures under 3 kilometers. Roughly 1 in 4 barrels traded worldwide travels this route. Any disruption, even temporary, could halt factories across China almost immediately. Prices would spike. Supply chains would feel immediate effects. Impacts would extend globally since many industries depend on Chinese production. Strategists refer to this concern as the Malacca Dilemma. It is not recent. China has addressed it through pipelines across Central Asia, ports in Pakistan and Myanmar, and vast underground reserves holding months of supply. Yet none fully resolves the ocean crossing requirement. A Pakistan pipeline helps, but oil still arrives by sea. Reserves provide buffer time but eventually deplete. This vulnerability inspired every advance covered here, each addressing a different aspect. Fuel created from air. Consider producing jet fuel the way plants generate energy, using surrounding air, water, and sunlight. This is no longer theoretical. A Chinese facility demonstrates it. The process begins simply. Machines capture carbon dioxide from the atmosphere, the same gas linked to climate concerns. Rather than allowing accumulation, they collect and prepare it for use. Solar power then drives equipment splitting water into oxygen and hydrogen. Oxygen releases back into the air. Hydrogen becomes the key component, a recurring element throughout these developments. Combining captured carbon dioxide with hydrogen under controlled conditions creates liquid fuel identical to traditional sources at the molecular level. Aircraft engines detect no difference. The company Carbonology opened operations in Shanghai's Lingang district in January 2026. Current output remains modest at 100 tons annually, sufficient for validation. Plans call for expansion to 1,000 tons, then 5,000, targeting 100,000 tons yearly by 2027. That volume could support thousands of long-haul flights. Major investors including Sequoia China and the Yellow River Delta Fund have committed resources. Airlines show interest due to emerging regulations requiring cleaner fuel blends. Demand existed in policy before full supply scaled. This addresses one energy challenge. Another persistent issue involves timing. What powers systems when sunlight fades? Energy stored in frozen air. Solar and wind generation face intermittency. Sunlight varies, and winds are unpredictable. Even extensive battery installations typically last only 4 to 5 hours. That suffices for brief gaps but not extended periods or continuous industrial needs. Hospitals cannot pause. Factories face costly restarts. The gap proves both expensive and risky. Engineers in the Gobi Desert pursued an alternative. They liquefied air. Ordinary air cools to approximately -194 degrees Celsius, transitioning from gas to liquid for storage. When needed, warming releases expanding gas that drives turbines and generates electricity. The facility pairs with a 250-megawatt solar array. Daytime surplus powers additional liquefaction. Nighttime release sustains operations for 10 hours. This exceeds typical battery duration and avoids rare materials. Output reaches about 180 gigawatt-hours annually and has operated since late 2025. This is a functioning plant, not experimental. It mitigates nighttime supply challenges, a major obstacle to reliable clean energy. Yet certain applications require actual fuel rather than electricity. The solution involves a common chemical: ammonia as an energy carrier. Ammonia, familiar from household cleaners, contains hydrogen. Burning pure hydrogen produces only water vapor. The challenge lies in transport. Hydrogen's low density requires compression or extreme cooling for shipping. Ammonia allows safe hydrogen storage and transport as liquid, with extraction at destination. It functions like portable packaging for clean energy. Traditional production demands high heat, pressure, and fossil fuels through the century-old Haber-Bosch process, a major natural gas consumer for fertilizer supporting global food supplies. In Shaanxi province, a facility produces ammonia differently. No fossil inputs. Nitrogen from air combines with solar-powered hydrogen at room temperature. It is operated continuously over 50 days with high reliability. This extends beyond agriculture. Shipping could adopt ammonia fuel. Japan and South Korea test ammonia-powered vessels on active routes. If maritime transport, moving 90% of global trade, shifts, oil dependence decreases. Fuel becomes optional rather than essential. This alters leverage entirely. Hydrogen as the connecting element. Each advance relies on hydrogen. Synthetic fuel incorporates it. Frozen air storage benefits from clean power enabling hydrogen production. Ammonia requires it as primary input. Hydrogen links these efforts. National output grew from 23,000 tons in 2019 to 125,000 tons in 2024, nearly sixfold. Guangdong province alone plans 80,000 tons annually from one offshore wind project. China produces about 65% of global electrolyzers, the equipment splitting water into hydrogen. Whoever controls this hardware influences transition speed worldwide. National policy elevates hydrogen alongside traditional sources with substantial funding. Targets aim for cost parity with oil soon. Even traditional energy firms adapt. One major refiner redirected nearly 800 million yuan to convert facilities for synthetic fuel. The shift proves tangible. The ultimate power source. All previous technologies depend on variable inputs. Solar requires light. Wind needs a breeze. Storage manages gaps but cannot create steady supply. Fusion offers constant output. It fuses light atoms at extreme temperatures, releasing energy like the sun. Fuel derives from hydrogen in water, abundant globally. China's East Tokamak achieved extended stable reactions exceeding previous records. It surpassed technical thresholds once considered difficult. Fusion remains developmental, years from widespread use. Yet investment and progress continue. Paired with earlier advances, It completes the system. Jet fuel production scales without limits. Hydrogen output multiplies. Frozen storage supports reliable grids. The cycle uses air, water, and power to yield fuel, chemicals, and electricity. No extraction. No vulnerable shipping routes. No geographic dependence. Power shifts from resource ownership to technology mastery. China leads in solar manufacturing and electrolyzers while exporting new energy infrastructure. Over 1 billion gallons of renewable fuel capacity advances. Hydrogen multiplies. Refineries convert to synthetic inputs. Construction occurs now. The oil era did not declare its end. It gradually yielded to faster, cleaner alternatives impossible to interrupt. One plant, one technology, one nation building, while others debate transition reality. If this offered new perspectives, like the video, it supports continued work. Subscribe and enable notifications for deeper connections in upcoming content. What country seems least prepared if energy becomes producible anywhere from air and water? Share thoughts below.